Good afternoon. For our next session here, Alex Monahan will be talking about taming file zoos. Alex says he probably won't have time to take questions in here, but he is willing to take questions out in the hall afterwards. So let's give Alex a big hand.
Thank you. All right, welcome everybody. Thanks so much for being here. Towards the end of the conference, really appreciate you. I'd love to talk to you today about taming file zoos, doing data science with DuckDB database files. First, I'll say howdy. Howdy, I'm Alex Monahan. My background is industrial and systems engineering from Virginia Tech, and then I spent 9 years at Intel breaking into the data world, starting as an industrial engineer, becoming a data analyst, and then a data scientist. In 2020, I discovered DuckDB, and it was a perfect fit for what I was working on at Intel. So I tweeted about it a ton, and I actually got recruited to do some documentation and blogging by DuckDB Labs. DuckDB Labs is the company that's founded by the creators of DuckDB, Hannes Mühlhausen and Mark Rosfeld. It's a group of 20 database researchers based in Amsterdam. And so I continued to work there part-time. And then, about 2 years ago, I decided to do all DuckDB all the time, and I joined a company called MotherDuck. MotherDuck is building a cloud data warehouse with DuckDB at its core. And we think having DuckDB as our core means that we can be fundamentally more efficient and more performant as long as you don't have Google levels of scale. We think there's so many companies out there, so many people where we can do things more efficiently as long as you don't have petabytes or exabytes. And part of our secret sauce is that we actually can use a combination of server-side and local resources, even in the same SQL query. So you can run one query, and part of it will run on our server, part of it will run on your laptop. And the part that's on your laptop is free and with no network lag. So a lot of cool opportunities for advanced data visualization, really fast interactivity. But I'm here today on behalf of DuckDB Labs, talking all about the open source project, DuckDB. So in data science, if all of our inputs were perfectly clean, all in one file, our lives would be easy. But we know that one file is easy, but files in the aggregate are really hard. You could have all different kinds of file formats. You've got flat files of all different shapes. You've got binary files like parquet, table lakehouse formats like Iceberg, Delta Lake, and then a huge long tail of other places that data can come from. Spreadsheets, statistical files, and if you're in the geospatial industry, you've got quite a lot of files that could be in use. Not only that, some of these files can be huge, or you can have thousands of them, and you really need the ability to handle all of those edge cases to get the insights out of the data to help the business. Not only is there a huge variety of files, they can live everywhere. They're probably not all already on your laptop when you start the project. They're scattered everywhere, all the different clouds, all over. And sometimes, when you get a CSV from a stakeholder, you might say, that's no CSV, that's an abomination. And you'd be right. Sometimes data is messy, and we need to be prepared for that and be able to handle it. And sometimes the problem is actually past me. Sometimes I am the one creating the file zoo because I'm iterating rapidly through my data science workflow. So I could have final, I could have final, I could have final, v3. Any other finals? Anybody? Raise your hand also if you've had at least a v4. Okay, that counts. All right, yep. We've all been there. We build this ourselves because this is an iterative process. And this is the sequel to that. Sometimes you have to fix just a portion of your analysis. And so now one of your files stays the same, but you actually should use this other file over here. And it gets to be tougher and tougher to keep track of as the project grows and grows. Has anyone ever crashed Python, accidentally hit Control-C when you didn't want to? Maybe your laptop battery died? Well, if you were in the middle of writing out a file, good luck reading that file. That file's going to be corrupted. It's going to be broken halfway through, and it's going to be difficult to recover any useful information out of it. And if you're lucky enough to be using parquet files, one does not simply edit a parquet file. You must rewrite the entire file, or create another one and use both. So with parquet, how do you output just a tiny bit more data? Well, yeah, I'm going to need you to work the weekend. I'm going to need you to replace the entire file. Or just add another one, and another one, and another one. You can solve some of those problems with a flat file. Sure, just add another row. But what data type was that? Who knows? And I hope you didn't want it to go fast. It's not very fast to write out a fully flat text file, especially with large data sets that we're working with. You could use a table lakehouse format. Sure, they'd be happy to add another parquet file under the hood, but then you got a lot of metadata you've got to write in a lot of different places. You got to talk to your catalog. It's not necessarily a fast or easy process either. So let's talk a little bit about DuckDB, and then we'll talk specifically about how it can help with these file zoos. So DuckDB is an open source analytical database as a library. The analogy we like to use is we like to call ourselves the SQLite for analytics. But let's unpack the phrase a little bit. It's open source, it's MIT licensed, you can use it for anything, commercial or otherwise. And it's an analytical database. So it's focused on large bulk transactions, the things you're doing in data science, processing 1 billion rows, processing terabytes of data. And it's built on cutting edge research from the database research community. But being cutting edge is not enough. You don't want to be the one being cut by the cutting edge. It has to be simple. It has to be robust. It's got to be production ready. And DuckDB went 1.0 almost a year ago. And we also take ease of use very, very seriously. That's why we're packaged as a library. You don't have to have a separate server running your DuckDB. You just import DuckDB at the top of your Python file, and you use it like you would any data frame library or SQLite. And that means it's an in-process database. Another word for that is an embedded database. So it lives inside the same Python process as your Python interpreter, which gives it some extra superpowers we'll talk about. So to use DuckDB, you pip install DuckDB. It's about a 20 megabyte file. It's precompiled for almost every platform, except for there's always one that's a little different, but precompiled for all the ones that we know about. And it has 0 dependencies. So it's very easy to add to your existing project. We won't cause any dependency conflicts. Then to use it, you just import DuckDB. You can create a connection. You can connect in in-memory mode if you'd like. But in this case, we're going to connect just to a path to a file. And if the file doesn't exist, we'll go ahead and create it, just like with SQLite. And then that will be your persistent DuckDB file that you get to work with. And at that point, then, you can start analyzing data. You can run SQL directly, pulling from CSV files, or use our relational API. So just a few lines to get up and running with DuckDB. Not only can you use it in any .py script that you'd like, we also have a number of different ways you can work with DuckDB in notebooks. So this is a look at a SQL-only IDE. This comes bundled with the DuckDB command line tool that you can download separately. And this is the greatest way to author SQL that I've ever seen. It is so fast, we sample your data when you go into this instant SQL mode. We sample your data and we can run the SQL statement on every keystroke. We can parse it, we can bind it, we can look for error messages. And we also will even allow you to inspect all of your CTEs with the click of a button. So you can actually see all of the intermediate steps that produce your final output. This, to me, solves a huge problem with debugging SQL. So if you're a SQL fan, give it a try. It's free to use. Just check out the DuckDB CLI. But we're at PyCon. So if you want to mix and match SQL and Python, Jupyter is a great place to do that. You can download another library called JupySQL, and you can turn a cell into a SQL cell with just %%SQL. And then you get nice syntax highlighting, and you can have that return a data frame out of it, and you can just alternate back and forth. One cell Python, one cell of SQL. Similarly, there's a modern notebook on the market now, Marimo. It's open source. And this actually has DuckDB as a first-class citizen, where there are DuckDB-typed blocks in Marimo. They're here around the conference. I encourage you to find them. Another superpower of DuckDB that really makes it helpful for data science is that we don't believe that you should have to wholesale switch to DuckDB. We want to interoperate with the ecosystem, with the community. So this is an example of interoperate with pandas. You can create a pandas data frame, and then you can say duckdb.sql, select the average of A from mydf. And you might say, Alex, what's happening there? I didn't pass in that variable. How did it figure out where to read this data from? That's just a string. Well, what we actually do is the first thing we check, is mydf a table in your database? And if it's not, we don't give up. We check your Python local variables, and we look for a variable named mydf. And then we check the class. Is it a class that we know how to read? Is it pandas? Is it polars? Is it Apache Arrow? If it's any of those, we can both read and write those formats. And it's zero copy because we are an embedded in-process database. We already live right where they are. We don't have to copy it first, don't have to send it over a socket. So this is very, very fast. So it's truly a great design pattern, actually, to alternate between a data frame line of code, SQL line of code, data frame again. There's really no overhead. As you can see at the very end of this, I can get things right back in a pandas data frame with .df. So that's a little bit about DuckDB. How can it help us as we're fighting through and taming these file zoos? It's not a coincidence that DuckDB can read all the files on this slide, because I built this slide. But an important thing to note here is that this is not just developed by the core DuckDB developers. These also come from community extensions. So all of the statistical package readers came from a community extension. The Google Sheets reader and writer also from a community extension. So DuckDB is very extensible. So if there's a file format that you don't see up there that is important for you, there's a path. So once we can read these files, it's not enough to just be able to read it. We don't want this to be a fight or a struggle. We want this to be seamless. So DuckDB has SQL, as we'll see, but we also have a full relational API. So it can feel much more like Python. So in this case, I import DuckDB, I connect, and then I can use read CSV. Looks a lot like the pandas function we were inspired by. And not only can you point to one file, you can point to a whole glob of files, so a whole directory of files. And we will look at those files, we will sniff them, we will look at the column names and the data types, we will deduce them automatically and pull them in for you to interact with. DuckDB operates lazily, so we don't read in all those files all at once. So you can do things like just show me the top 100 rows and we'll only read 100 rows. Or like in this last step here, we're going to go ahead and create a DuckDB table based on that data. But we're not going to read everything into memory and then write it out to DuckDB. We're going to stream it straight from one file to the other, so you can work with arbitrarily large files and convert them into the compressed DuckDB format, so you can work with them over and over. Another alternative to the relational API is the friendliest SQL in the world. And I think that sounds like a bold statement, but I truly believe it. You can see an example here at the beginning. Select star is optional in DuckDB. Why do we need select star? It means you want everything. Okay, well, we'll just assume you want everything, and if you want less, you can tell us. So we start with from. And then instead of having a special copy statement to then exactly specify how you want to read these particular files, you can just point us at a path, and we'll treat it like a table. And we'll deduce all the column names and all the column types and just read it. Once again, this is lazy, so you can just preview the files if you'd like, or you can fully analyze them. And then you can see this last SQL statement is creating a table based on this, and it's doing the same thing as before, streaming the data from the CSVs straight into a DuckDB format file. And these files live everywhere. DuckDB can pull from all the major clouds. You can pull from all the major clouds in the same query if you'd like, mixing and matching, as well as some of the other places like MinIO or Cloudflare R2. And that same friendly SQL also works in the cloud. So it's not any more complicated to work with data scattered everywhere that we have to deal with as data scientists. We can create a secret. This is an S3 type secret, and we just tell it to use our credential chain, which means we already did single sign-on with AWS SSO login. How many times have we typed that? And instantly we'll use those credentials to access AWS for you. And then the same SQL works. All you change is the path. Point to the S3 path. And once again, you can glob, so you can look at an entire bucket worth of files, all in one statement. I also want to make the case to you that DuckDB is the #1 way to read CSV files. And I want to show you a benchmark of it. And you might be thinking, oh, does that mean that it's the fastest? I'm not going to try and make the case that we're the absolute fastest, but we care deeply about performance. And I'm not going to try and make the case to you that we're going to be the lowest memory. Although we are streaming off of disk and streaming back to disk, we are deliberately very wise with our memory management. I'm going to try and make the case to you that we're leading in the metric of most likely to actually read the file. And you might say to me, Alex, how hard could it be? It's a CSV file. It's got commas, it's got new lines. How hard could it be? And if you've seen this show, Top Gear, whenever Jeremy Clarkson says this, it means he's really in for it, okay? It's never as easy as you think. So there's actually a benchmark for this, the Polloc benchmark. And they looked at 245,000 CSV files. What a job. 245,000 CSV files from government entities across 6 continents. So this is not just CSV files uploaded by, random people on the internet like me. This is from our governments of the world. And they found some messes. So this is one example. Some rows are just missing the last column. And it might be because these train stations, had no delay. So they saved like 3 whole characters by not including a delay of 0. Like, thank you, you broke half the CSV readers out there. Really appreciate that. My favorite thing whenever I export things from my bank, they've got like 10 header rows that tell me nothing. Why is that? This is not helpful. I just want 1 header row and then I want my data. Not only that, maybe you're editing this file iteratively back and forth, different operating systems. You have different new line characters. What a frustrating tiny detail that can also still break things. Or maybe you just don't bother escaping quotes. So we have no idea where the end is to any of these strings. There is no escape. And some of these CSV files don't even use commas to separate the values. What does CSV even mean? What do words mean? What do acronyms mean? Do we believe in anything? But maybe we'll allow it. Maybe we'll allow it, as long as it's ducks. So this is a look at the benchmark results. DuckDB is actually the most likely to read your files. But this is not competing against formats you've never heard of. This is the creme de la creme of dealing with messy data. These are the tools that we reach for when we see these kinds of problems, because they're great. You got SQLite, you got LibreOffice, you have a mysteriously named spread desktop, an industry-leading desktop spreadsheet. You have a mysteriously named spread web, an industry-leading web-based spreadsheet that we shall not disclose to protect the innocent, or Python directly to the native CSV reader in Python or pandas. And we were inspired by the way that pandas parses CSVs, but we recognize that that is a huge thing people love pandas for. And we also wanted to really be investing in the things that are actually practically useful in data science, which is dealing with messy data. So now that we've read a variety of files, they live in a variety of clouds, and we've read the dirtiest, grungiest CSVs that our governments can provide us. Now, how do we not create a file zoo ourselves? And we can do that by using the all-in-one DuckDB file format. So let's take a look at what does that format look like under the hood. So this is looking at one database file. I like to use the extension .duckdb, but you can really use any extension you'd like, so get creative. And within that, you can store as many tables of data as you'd like. And in addition to just storing tables, we can also store a lot of metadata. We can store SQL views, SQL functions, to actually store your processing logic on top of those tables. You can store primary and foreign key relationships, so you can define how things are actually meant to map together between those tables. But if we look specifically at tables, like table 1, you can see it's broken up into chunks of row groups. And so let's look deeper at row group number 1. So row group number 1, this is about 120,000 rows in a row group. And what we do is we store things column by column within this row group. So DuckDB is a columnar file format. And what that allows us to do is compress the data really well. In a row-based format like SQLite, you might have a column that is a date next to an integer, next to a string, next to a float, and those don't have a lot in common, which means they're really hard to compress. But with DuckDB being a columnar format, integers all look pretty similar. Dates tend to all be very close together, so they compress very, very well. So you'll typically see 5 to 10x compression compared with a row-oriented format. But not only that, we also don't want to just store data, we also want to store metadata. So you can see that we store the minimum and maximum of each column in this row group. And what that allows us to do is if we're running a query where I want to look at table 1, where column 1 is greater than 9,000, it's over 9,000, I can skip this entire chunk because I already know everything here is 9,000 or lower. And that allows us to only read off of disk what we actually need for the individual query that we have. There's a lot of other things to like beyond just the format itself. It's MIT licensed, which means it's totally open source. You can see the full implementation. And it's backwards compatible. So since DuckDB went 1.0 last year, we can actually read all those files with the latest DuckDB version, even back before 1.0. And we're committed to maintaining that for several years. We think that's really, really important if you want to store files for a long period of time. It's also a cross-language format. You can read it in 15 different languages: Python, R, Java, JavaScript, Rust, Go, C++, C, really across the board. Makes it really useful to pass to any of your colleagues. As we saw, it's columnar and it's compressed. It's compressed using techniques that are called lightweight compression, which allows it to be very fast to read and write as well for your CPU. And as we saw, it's a single file. You can store tables, many tables, and relationships between them. And as a part of that, we haven't really talked about this part yet, is that it is actually editable. So because we want to be able to store multiple tables, we need to be able to write to this file multiple times. But not only can we append to this file, you can delete individual rows, you can update rows, you can add columns, you can really fully and completely modify this file, which makes it very, very flexible, especially if you're working locally. And DuckDB is really designed, part of the reason DuckDB exists is because Hannes and Mark went and met actual data scientists. Computer scientists went and talked to people. It's not always common. And the goal was to understand why they didn't love databases. They're like, hey, we're database people, you're data science people. Don't you love databases? Aren't they so cool? And they looked at it and said, well, no, not really. We don't really love databases. They add a lot of overhead. They're very painful. And so that's why we have such an easy to install format. That's why we operate in process instead of a separate server. So we've tried to learn a lot from the data science community in the core design of DuckDB. We also want to bring some of that database research over into data science and some of these hard-won kind of principles and properties of databases. And some of those are the ACID principles. So ACID is an acronym, and it's all about just leveraging some of the hard-won database wisdom of just error cases that are very tough. And so the first one, A, stands for atomicity. And this means that change is all or nothing. So you can set up a group of changes where you want to insert into several different tables. Maybe you want to delete from a table and insert. And you want to make sure that you don't do just one of those things and not the other. It's either all or nothing. And that's really helpful if you want to do incremental file import, where you don't want to have duplicates by accident. You want to delete and insert atomically. It's very, very helpful. How else can it help in data science? Well, there's also the ability to undo changes. You can begin a transaction, you can insert your data, and then you can test it. And if your tests fail, you can roll it back. And your data is as if it was never inserted. So it's very powerful to have that kind of undo primitive all the way down to storage on disk. C is for consistency. This helps prevent data quality problems before they happen. And this is largely based around primary and foreign keys. Primary keys allow us to detect duplicates and let you know when things are being duplicated. And then foreign keys allow us to let you know when tables are missing data that should be there in other tables. So if I go and insert a set of order data that happen to be ordered by certain customer IDs, I might want to check if I have that customer ID in my customers table, or if maybe there's some kind of issue in my data. And this allows it to be an upfront error rather than silent data corruption, where I just have missing data. Isolation is all about allowing multiple queries to run at the same time without interfering with one another. So that means that I can be inserting data with one query and reading data with another, and I won't read that data that's being inserted until it's committed. So there's no crosstalk between queries. DuckDB has a full multi-version concurrency control system. So as a data scientist, I can do things like be updating in the background and visualizing at the same time. And I won't get partially updated data while I do that. Durability means that once you commit that data, once you finish that insert, once you commit that transaction, your data is safe. We're going to write it all the way to disk, to where it's ones and zeros on some sort of storage medium and not in some operating system cache. And that means that we can prevent file corruption. And because we have this kind of snapshot commit process as well, if your battery dies midway through writing data, we have the ability to roll it back. And we can allow that file to continue to be used without being corrupted. So in summary, DuckDB can really help bring order to the chaos that we dig through to add value as data scientists. We can read a huge variety of data formats. We can read them all across the clouds. And we can tame some of these really wild real-world CSVs that are out there. Not only that, once we're done, we can output all of our results all in one file. So that way it's easy to transfer to our stakeholders, easy for future me to understand when I go look at it in 6 months. It's also built and designed for speed, for the bulk transactions we do in data science, because it's columnar and it's compressed. And we can still edit it. So we can work incrementally, we can add columns, we can add rows. Excuse me. And finally, we can depend on the hard-won database wisdom of ACID. And so with that, I'd like to say thank you very much for your time and your attention, and personally welcome you to the flock. All right, I'm happy to answer questions now if we have time, otherwise outside.
Yeah, we actually have about 4 or 5 minutes. If there are any questions, we can take a few here and then more outside.
I'm curious if you could briefly speak to some of the GIS features you mentioned kind of in the intro.
Maybe come talk to me afterwards and I can at least find some resources for you. It's a deep field. It's an entire field. We have a spatial extension. We integrate with GDAL, and so we are able to read all the formats that it can, and then we have some geospatial data types that allow you to do some efficient processing. But come find me.
Hi, I'm actually using DuckDB to a small degree because of a library that I use and love. My biggest hesitancy is actually having to write SQL in quotes. You ever thought about creating like a Lambda-style syntax for this language? You know, like link Lambda, something along that line. Probably too many years of looking at vulnerable PHP code. I can't stand SQL in quotes.
Sure. Yeah, we do have the ability to do prepared statements, so you can parameterize, and the quotes will be escaped to prevent SQL injection. We also have our relational API. We have an experimental PySpark API as well. And I think the SQL notebooks are also a really great way around that as well. You can have those SQL cells. Excuse me. All right. Other questions?
Hey, hello. I have one question. Can you use this tool to write back into a SQL database or just kind of analyze data pulling out of? And second question, I don't know if I remember if you show, can we read Excel files or just CSVs?
Great question. Yes, we can actually read and write to multiple different SQL databases. Excuse me. We can read and write to MySQL, Postgres, and SQLite. We can also read from BigQuery. We can also read Apache Arrow, which means that you can pull from Snowflake with ADBC, and you can read that very nicely with DuckDB as well. We can also read and write Excel files. So we do have a full Excel reader and writer. Great questions. And I didn't plant him, but I did mean to talk about that on a slide, so thank you. All right. Well, thank you all so much. I'll be out in the hallway. Cheers.